This video is the second part of partial differentiation, so let's have some examples. In number 1, you're given a function in terms of x and y equal to y cosine x squared plus y squared. So we have to find the first partial derivative of f with respect to x and with respect to y. So f sub x, meaning the partial derivative of f with respect to x, when we differentiate the function, will take all y always constants. Okay, so y and y squared are constants here in this differentiation process. So y is a constant, so I'll just copy y in this function. So taking the derivative of cosine of x squared plus y squared, using the formula, it's leading to negative sign of x squared plus y squared times the derivative of x squared plus y squared with respect to x. So we'll take y squared as a constant, so the derivative of the angle is just 2x, because the derivative of y squared, because it's a constant, is just equal to 0. So f sub x is just equal to negative 2xy sine of x squared plus y squared. This is the partial derivative of f with respect to x. And for the partial derivative of f with respect to y, we'll take x as a constant. So this will be a product of y and cosine x squared plus y squared. Right? So in the product rule, this is u, and then this is v. Right? So product rule. So it's y times the derivative of cosine of x squared plus y squared. So it's u times dv, which will give us negative sign of x squared plus y squared times the derivative of x squared plus y squared with respect to x. So since x squared is a constant in this differentiation process, the derivative of the angle will just be 2y. Okay, plus v times du. It's cosine of x squared plus y squared times du, which is just equal to 1. So the derivative of y with respect to itself is just 1. So let me just write the answer. It's negative of 2y squared sine of x squared plus y squared plus cosine of x squared plus y squared. This is the partial derivative of f with respect to y using product rule. Now let's have another example. So in number 2, you're given capital F in terms of x and y, which is equal to 2 sine x cosine y. We have to find the first partial derivatives of f with respect to x and y, and then the 4 second partial derivatives of f. Alright, so let's start with the first partial derivative of f with respect to x. So in this differentiation, we'll take y as a constant. So therefore, in the function f cosine y will be a constant in this process. So we'll have a constant 2 cosine y in the first differentiation, and then the derivative of the remaining expression, which is sine x with respect to x, is equal to cosine x. Okay, so this is f sub x. And then this first partial derivative of f with respect to y. So in this differentiation process, 2 sine x is a constant in the function f. So just copy that constant and take the derivative of cosine y with respect to y, and that is negative sine y. And write negative here, negative 1 before the constant. This is capital F sub y. Now let's go to the second partial derivatives. So we'll have the second partial derivative of f with respect to x, first partial with respect to x also. So we are differentiating this function with respect to x. So in the differentiation process, y is again a constant. So 2 cosine y is a constant, and the derivative of cosine of x with respect to x is negative sine of x. So this is the second partial derivative of f with respect to x, first partial with respect to x also. And then we'll have the second partial derivative of x with respect to y, first partial with respect to x. You're still differentiating the same function with respect to y this time. So 2 cosine x is a constant, and then the derivative of cosine y is negative sine y. So this is the second partial derivative of f with respect to y, first partial with respect to x. Now let's go to the second partial derivative of f with respect to x, first partial with respect to y. So this time we're differentiating this function with respect to x. So we'll take sine y, a constant here. So negative 2 sine y is a constant. The derivative of sine x with respect to x is cosine x. This is f sub yx. And then finally, the second partial derivative of x with f with respect to y, first partial with respect to y. We are still differentiating this function with respect to y this time, so negative 2 sine x is a constant. And then the derivative of sine y with respect to y is cosine y. So this is the second partial derivative of f with respect to y, first partial with respect to y. As you can see, these two functions are still equal because f is continuous. Now for the third one, z is written in terms of x and y. So it's x cubed plus y squared quantity raised to the 6th power. So we'll have to find all the first and second partial derivatives of z. So I'll start with the first partial derivative of z with respect to x. So in this case, y is a constant. So using the general power rule, we'll have 6 times x cubed plus y squared raised to the 5th power times the derivative of the base with respect to x. So it's 3x squared plus the derivative of y squared. Since y squared is a constant, so the derivative is just 0. So the first partial derivative of z with respect to x is equal to 18x squared times the quantity x cubed plus y squared raised to the 5th power. Alright. Now for the first partial derivative of z with respect to y, in this case, we'll take x as a constant. So using the general power rule again, we'll have 6 times the quantity x cubed plus y squared to the 5th power times the derivative of the base with respect to y. Where the derivative of x cubed is 0, we'll have 2y only. So the first partial derivative of z with respect to y is equal to 12y times the quantity x cubed plus y squared raised to the 5th power. Now let's go to the second partial derivatives. The second partial derivative of z with respect to y, no, with respect to x first. Okay. So first partial with respect to x, so we're differentiating this with respect to x. So we need to use the product rule here because this is the product of u and v, where u is x squared and v is the power of x cubed plus y squared to the 5th. Okay, 18 is just a constant, so I will just copy 18 and take the derivative of u times v using product rule. So it's u times dv, so x squared times dv using general power rule, it's 5 times x cubed plus y squared to the 4th power times the derivative of the base with respect to x, and we'll have 3x squared. The derivative of y squared again is just 0 in this differentiation. So plus v x cubed plus y squared to the 5th power times the derivative of x squared with respect to x, which is 2x. To simplify this, I will just have to write the answer in factored form. So I'll just factor out all common factors between the two terms. These are the two terms, first term, second term. Common is x and the power of x cubed plus y squared to the 4th. Alright, so factoring this expression from the first term, I mean, you'll have, so multiplying the constants 5 and 3, you have 15, and then multiplying x squared and x squared, you'll have x to the 4th, but then x is factored out already, so x cubed only. And then this is factored out from the second term. So factoring from here, factoring x cubed plus y squared to the 4th power, you'll just have x cubed plus y squared to the 1. Okay, so the exponent of x cubed plus y squared will just be 1. And then from 2x, we factored out x already, so what remains is 2. And then removing the grouping symbols to simplify our answers. So 15x cubed, distribute 2 inside, you'll get plus 2x cubed plus 2y squared. And then just combine like terms inside the parentheses in the last factor. We have 18x times x cubed plus y squared to the 4th power times the quantity 17x cubed plus 2y squared. Right, so this is the second partial derivative of z with respect to x. First partial with respect to x. Okay, now let's take the second partial derivative of z with respect to y, first partial with respect to x. Alright. So we are still differentiating this function, this time with respect to y. Okay, so in this case, 18x squared is just a constant because we are differentiating with respect to y. So using general power rule to differentiate the power of x cubed plus y squared to the 5th, you'll have 5 times x cubed plus y squared, this time to the 4th power, times the derivative of the base, x cubed plus y squared with respect to y, so we'll just have 2y. Because the derivative of x cubed here is just 0 when differentiating partially with respect to y. So the second partial derivative of z with respect to y, first partial with respect to x, is equal to, we have the constants 18, 5, and 2. 18, 5, and 2. Multiplying them, we'll get 180 x squared y times the quantity x cubed plus y squared to the 4th. This is our final answer. Now let's go to the second partial derivative of z with respect to x, first derivative with respect to y. Okay, z with respect to x, first partial with respect to y. So in this case, we are differentiating this with respect to x, so therefore 12y is a constant here. And then the derivative of x cubed plus y squared to the 5th power with respect to x, it's going to give us, so using power rule, 5 times x cubed plus y squared to the 4th power times the derivative of the base x cubed plus y squared with respect to x. So it's going to give us 3x squared because the derivative of y squared is just 0. So this is equal to, so multiplying the constants, 12, 5, and 3. So 12 times 5 is 60 times 3, 180. And then x squared y times the quantity x cubed plus y squared to the 4th power. Alright, this is the second partial derivative of z. Oh, I forgot the exponent. Second partial derivative of z, just rewrite this, with respect to x, first partial with respect to y. Alright, so these two are still equal because z is continuous. Okay, now we go to the last one, the second partial derivative of z with respect to y, first partial with respect to y also. Okay, we're still differentiating this function, this time with respect to y. So using product rule again, because this time this is a product of y and x cubed plus y squared raised to the 5th power. So in this differentiation, 12 is just a constant, so let's just copy the constant and get the derivative of the product of u and v with respect to y. So it's u times dv, so y times the derivative of the power of x cubed plus y squared to the 5th using power rule. That's 5 times x cubed plus y squared to the 4th power times the derivative of the base with respect to y. So the derivative of this base with respect to y is just 0 plus 2y plus v is x cubed plus y squared to the 5th power times the derivative of y with respect to y, which is just equal to 1. Right, so let me just factor out what's common between the two terms. So it's the power of x cubed plus y squared to the fourth. So upon factoring this expression from the first term, this is the first term, we'll just be left with the constant 5 times 2. That's 10. And then y times y is y squared. Okay. Plus factoring x cubed plus y squared to the fourth, we'll just be left with x cubed plus y squared plus y squared. Alright. So just combine like terms and we'll have 12 x cubed plus y squared to the fourth power times 10y squared plus y squared is 11y squared plus x cubed. This is the second partial derivative of z with respect to y. First partial with respect to y. Alright, that's it.